Hey, today we're going to talk about some word problems with variables on both sides. But first, we are going to talk about on page 13 and 14. I asked you guys to try 3 problems. So we're going to go ahead and first go to page 13 in your notes. And so you should be getting this out as well. Okay, so on page 14, I asked you guys to try these 2 problems, the friends and the cheeseburger problem. So we're just going to discuss it real quick, make sure we feel okay with it, and then we'll move on to variables on both sides. Okay, so for page 14, 3 friends each bought 2 slices of pizza and a drink at the mall. If drinks cost 75 cents and the total of their order is $11.25, how much did 1 slice of pizza cost? Okay, so we have 3 friends, and each of them bought 2 slices of pizza and a drink. And the drinks, we know, cost 75 cents. Okay, so to represent this, one person would get 2 slices of pizza and a drink that we know costs 75 cents. Okay, but we know that there are 3 of them, so we are going to multiply everything by 3, and we know that the total cost is $11.25. Okay, so you could have written it that way, or you could have known, okay, if 3 people buy 2 slices of pizza each, you would have 6 total slices of pizza. If you had 3 people and each of them get a drink for 75 cents each, that would cost 75 cents times 3, so $2.25. So you could have also written it like this. And I mean, if you wrote it the first way, then you would simplify it anyway. Then we would get rid of the 3 drinks. Okay, so 6 slices of pizza would be $9. And then we would divide the $9 by the 6 slices, and we would get x equaling 1.5. So each slice of pizza would be $1.50. All right, for the other problem, James bought a cheeseburger, fries, and a drink for dinner. So here's the cheeseburger, here's the drink, and here's the fries. Okay. The cheeseburger was 3 times the cost of the fries, and the drink and the fries were the same price. If the entire meal cost $12.50, what was the price of each item? So really, if we knew the cost of the fries, we could probably figure out the cost of the cheeseburger. So I'm going to say X is the cost of fries. Okay, because I don't know what this is. But if I knew how much the fries were, it tells me that the cheeseburger was 3 times as much. And it also says that the drink and the fries are the same exact cost. So I'm going to use the same amount. Okay. It says the entire meal. So if I add all of it together, I should get $12.50. So that is one way to represent this problem. But if we were to combine all of these x's together, we would get 5 x's equaling $12.50. If I were to divide by 5, $12.50 divided by 5, I would get 2.5. So that is the cost of the fries, so $2.50. The drink was the same exact cost, so $2.50. And the cheeseburger was 3 times as much. So that would be $7.50. All right, now we're going to go on to variables on both sides. So this was on page 14, and we've been taking our notes. And so now we are on page 17 and 18. All right, Hudson and Knox are in a race. Hudson is running at a speed of 8.8 feet per second. Knox got a 30 feet head start and is running at a speed of 6.3 feet per second. How many seconds will it take until Hudson and Knox are in the same place? Where in the race will they be? Okay, so the question is how many seconds will it take until Hudson and Knox are in the same place? So I'm going to say that X is the number of seconds. Okay, and the question is, when will Hudson and Knox be in the same place? And so when I think of same mathematically, I mean equal. So I want to know, when is Hudson equal to Knox? So now we're going to go back into the word problem and find what numbers represent Hudson and what numbers represent Knox. So here we have Hudson is running at a speed of 8.8 feet per second. Okay, so 8.8 feet per second. Seconds is what our x is, so we're going to represent that by 8.8x. Then we have Knox, and Knox got a 30-foot head start. Okay? And after that, then he started running at a speed of 6.3 feet per second. So per second is where our variable is going to go. So we have 6.3x. Okay? We have to think about what goes in between them. We started with an additional 30 feet, and then he's increasing his distance, so we're going to add. So this is the equation that we can write. Now it says how many seconds, so we're going to have to solve this. So we're going to move our variable onto one side. So I'm going to do the opposite of adding 6.3x and subtract it. Okay. Then I would have 2.5x equaling 30. Then I'm going to divide by 2.5. Let's see. And 30 divided by 2.5 is 12. Okay. So x equals 12, and x is representing seconds, so it will be 12 seconds. Okay. It says how many seconds will they be in the same place and where in the race will they be. So we know that x is 12, so I'm going to plug in, you can either plug it into Hudson or you can plug it into Knox. They are equal, so they should get you the same thing. I'm just going to plug it into Hudson real quick. And Hudson was 8.8 feet per second. So for 12 seconds, we'll multiply 8.8 and 12 together and get 105.6. Okay? So at 12 seconds, they are both at 105.6 feet. Okay. You could also check Knox to see if you got the same thing. So 30 feet head start plus 6.3 feet per second. So for 12 seconds, that would be 75.6. 75.6 plus 30, which would be 105.6. So they are equal. They are the exact same. Okay. The second one, Isabel takes the bus to work. The bus ride to work costs her $2.50 each time. She could buy a bus pass for a one-time fee of $15 and would only have to pay $1 each time to ride the bus. How many times would she have to take the bus in order for the cost to be the same? So the question is, how many times would she have to take the bus? So x equals number of bus rides. Okay. So it says, when will the cost be the same? So basically there's two different situations. There's just if she goes every time and if she got a bus pass. Now I want to know when they are the same or when they are equal to each other. Okay. So we're just going to compare the two. First, if she doesn't get a bus pass and she just goes every single time, it would be $2.50 every single time, every single bus ride. So we're going to put $2.50 for every bus ride. Now, if she buys a bus pass, she would have to pay $15 up front. Okay? But after that, it would only be $1 each time. So here's the $15. And additionally, she would only have to pay $1 every single time. So now here's the equation. Here's $2.50 for every time. When is that going to be equal to the bus pass? $15 plus $1 every single time. So now we're going to solve it. And we get 10. Okay? So the question is, how many times will it take to take the bus in order for each cost to be the same? And it would take 10 times for them to be the same cost. All right, for this next problem, we are going to, this is a very literal problem. Some people don't love these ones, and that's okay. We're just trying to get better at our algebraic sense making. So we are going to decrease -5 times a number by 18, and that is equal to decreasing 9 times the same number by 25. Okay, so we're just going to say, x is the number. We don't know what that number is, but we're just going to represent it by a variable. So decreasing means to subtract. So we are going to subtract, friends, okay? And we are going to subtract -5 times a number, so times a number that we don't know, so we're using x. So -5 times a number, and we are decreasing that by 18. So decreasing -5 times a number by 18. So -5x minus 18. And that is equal to decreasing or subtracting 9 times the number, so 9 times x, and subtracting that or decreasing that by 25. So again, this is just a very little problem. You have to figure out what is it saying. It says decreasing, so we know that we subtract. We have 9 times the number, so 9 times x, and figuring out that we're taking that and subtracting 25 from it. All right, so now we are going to solve this equation. So we're going to move this 9x over, get -14x. Then I'm going to add 18. Get -7. And we get 0.5, or if you make that into a fraction, we get 1/2. Okay, so what I want from you guys is I want you guys to try these two problems. So go ahead and hit pause. And I want you guys to try on page 18. Just go ahead and try these two. Whenever you feel like you have at least attempted it, hit unpause and we will check together. All right, I hope that you guys tried these two problems. So we're going to talk about it and hopefully figure these out. Haley has $155 in savings and her brother Hank has $230. Haley is saving $10 each week, and her brother is spending $15 each week. After how many weeks will their savings account have the same amount of money in them? And how much will they have in each of their savings accounts? So x equals, we have to figure out the question, how many weeks? So number of weeks. And the question is, when will they have the same amount? So we're trying to figure out, when does Haley have the same or the equal amount as Hank, her brother? Okay, so Haley right now has $155 in the account. Hank has $230, so I'm going to put over here with Hank because we're comparing the two. Haley is saving $10 every single week. So it looks like she's adding to her bank account and she's saving $10 every single week. Every week, so we put the X. Okay. Her brother seems to be spending $15 every single week. So instead of adding, we're spending the money. So we're going to take out $15 every week because X is our number of weeks. All right, now we're going to solve this. So we're going to add 15x. And then we are going to subtract 155. Get 75. Divide by 25. And we get x equals 3. Okay. So how many weeks will it take for them to have the same amount of money? So the answer is 3 weeks. And it says how much will each of them have in their savings account? So you can either do Haley and do 155 plus $10 for every week. So for 3 weeks, that would be 185. And if we're right, Hank should have the same amount. So Hank had 230, but he spent $15 for 3 weeks. So that would be 230 minus 45, which would also be 185. So 3 weeks, they will both have $185. All right, this final one is again a very literal problem. 2 more than 16 times a number is the same as 21 less than the product of -7 and the number. So we don't know this number, so we're going to say x is the number. Okay, 2 more than 16 times a number. So 2 more, when I think of more, I think of adding to something. So I'm going to have adding 2 more, then 16 times this thing. So 16 times x. It says is the same as, so that means equal to, 21 less than the product of -7 and the number. So when I think of 21 less, I think of going down. So I'm going to subtract 21. 21 lower compared to -7 times that same number. So times x. So we have 16x plus 2. 2 more than 16 times a number. And that's the same as going 21 lower than -7 times a number. So now we are going to move our variable onto one side and get 23x plus 2. Then I'm going to subtract 2. Brogan, stop. And you get x equaling -1. So -1 is that number. All right, today, guys, you are going to have a Google slide problem with just 2 slides just to practice these word problems.